Hey, I'm John Buzikowski. Today we're going to be looking at symptoms and repair of refrigerant leaks. We're going to start with some of the symptoms of a leak and how you find them. Those symptoms could include low refrigerant pressure, low pressure trips, or oil staining on the exterior of your condenser coil. Units using A2L refrigerant have refrigerant sensors in the following locations: the bottom of the compressor tub wall, the supply blower section, and the coil section on the blower wall near the overflow switch. If any of these sensors detect a leak, they will initiate a safety sequence. This includes moving stagnant refrigerant from within the unit, duct, and space to ensure proper dilution. It also includes starting the supply fan. The unit can connect to a damper and send an open command when the fan starts so that ductwork is not damaged. The sensors will display one of 4 light codes to indicate the sensor status. Solid green is for sensor power-up and self-test. Blinking green is normal operation. Solid red is an alarm state, meaning gas has been detected. If the light is blinking red, replace the sensor. This example shows an Airstream sensor trip where the system has detected a refrigerant leak. Before starting to repair a leak, wait until the safety sequence is finished. Starting with low pressure trips, there is a way to look at your alarm history. So let's take a look at that first. To look at your alarm history and determine if low pressure trips have been happening in the past, first we're going to press the bullseye button. That'll get you into the main menu. We're then going to hit the up arrow until you see the alarm menu. We'll then press enter, and you'll see right here the alarm history. Another thing that you can do to determine if there's a leak is looking at your refrigerant pressure transducers. And then there is a way built in to the Corel platform that you can view the refrigerant pressures transmitted with our discharge pressure transducers. And even on inverter compressor circuits, you will have a suction pressure transducer that'll be providing pressure readings. Again, using the Corel interface, you'll press the up arrow. Even if it says end of menu, don't worry, you can just keep pressing up. This just brings you to the bottom of our menu structure. Continue to press the up arrow until you see this circuit B or circuit A pressure transducer values. Now, if you do not have refrigerant pressure transducers or you can't locate them, you don't see any information in the unit controller, our recommendation would be to get manifold gauges and connect them to verify refrigerant pressure. Let's do that now. If either circuit has abnormal pressure or leads to you suspecting a leak, now would be a good time to give our tech support group a call. Leaks found as a result of shipped product defect may be eligible for labor reimbursement. By contacting us, you may be authorized up to 4 hours labor to perform a leak search. Don't spend more than 4 hours looking for a leak before contacting us. Pictures or videos of leak locations are required for your final or complete reimbursement. Now that we have looked at our leak symptoms, let's look at locating a leak now. There's a couple methods to use. We could use a refrigerant leak detector. We could use dye in the system. And we can use soap bubbles. With using a refrigerant leak detector, it's typically best if the circuit is not flat or if you still have refrigerant in the circuit. You're going to want to just do a pass around the whole unit, looking at locations such as brazes, Schrader cores, pressure switches, coil fin packs, and coil U-bends. If your refrigerant leak detector does alert on any of those locations, we would still prefer if you follow that up by charging with nitrogen or simply performing a soap bubble test. For the sake of this, we are going to be adding nitrogen. I already removed the refrigerant just for the sake of this training exercise. Before we do that though, I do want to discuss why I removed both circuits of refrigerant in order to fix a leak on just one circuit. Okay, evaporator or cold coil section. The reason I brought you over here is to look at the circuit A and circuit B coil interlacing. What I referenced before was removing refrigerant out of both circuits prior to just fixing or brazing a leak on one circuit. Reason that is, if you follow these distributor lines, we'll use this top one for an example. We follow it down and it connects to circuit B. The distributor line directly below that, if you follow that, that actually goes over here to circuit A. Indicated typically on this bracket, you will actually see a label for circuit A and circuit B, and that's the same circuit that'll be labeled in your compressor section where we were earlier. Now, say we have a leak on this top, circuit B, and we're gonna have a torch in here brazing. There is a potential that your torch heat could loosen another braze joint on an adjacent circuit. We don't want that to happen. So I would say always remove refrigerant out of both circuits if you're going to be brazing on this section, primarily for the matter of safety. Okay, now let's spray down our coil section here. Let's start on, let's pretty much just spray everything down, all the U-bends, any soap that sprays out rapidly or just starts to create fine foam. In some cases, it actually is helpful to hold a flashlight looking straight up and down. You'll actually be able to see soap spraying out at you that wouldn't have created bubbles. Okay, we're spraying down distributors. Oh, here we go. We have a leak on, if we trace this out, looks like the circuit B distributor line. Next, let's get this leak fixed up, and then we'll transition on to vac and charge. All right, let's get my torch lit. So what we're looking for here is a balanced flame. Ideally, you want your flame length as short as possible, just considering the tight quarters that we're in. However, as I turn my torch up and get that shorter flame, I'll end up with a flame that's actually too hot for the pipe sizes here. So it's actually more ideal to just create as balanced of a flame as you can. And with this rosebud torch that I'm using here, I'm really just audibly listening for a quiet flame. That's kind of what we're looking for here in this case. In the field, you'll probably be using a turbo torch or something like that, where you have a little more control on the length. But this full-size torch, this is what we're looking for. Okay, let's start heating up this joint here. And we're looking to just slowly heat up both the coil side and the distributor line. We'll start to see our braze material change colors. And now I can add and just for good measure, we'll also add some here. All right, we'll let that cool down and then check it a second time. Okay, Okay, circuit B, we'll fill this with nitrogen. All right, our nitrogen's flowing into circuit B. Check with a handheld leak detection sensor to make sure no refrigerant remains in the system. All right, now that we have our leak brazed, we pressurize with 450 psi of nitrogen already. We're gonna spray again here, verifying this leak has been fixed. Okay, looks like it has. For the purpose of this training, we're going to go over to the front of the cabinet and then look at some other potential leak locations, how to identify them and fix them. Okay, now let's talk about the compressor compartment here and possible leak locations. We're going to start with, honestly, the more common locations and then go to some more obscure ones. The first place to always start is going to be Schrader cores. Make sure that the caps are secure. If they're missing, I would definitely start there. Pressure transducers and pressure switches. Probably the least common locations will be actual braze leaks, compressor seam leaks, welds around the bottom of the compressors and items like that. Let's spray down some of these more common locations. Let's start with our Schrader cores, since the caps are missing. When you spray down pressure transducers and any Schrader cores with soap, definitely helps to run your finger around them just to make sure that there's an even layer of soap around all these locations. For cores, it also helps to do the same thing. It actually looks like we're seeing a leak here. Okay, so for a leak on a Schrader core here, this could be the only leak that you have. What you have at your disposal to fix these, actually the caps that we provide with the units have a Schrader core tool built into the top of them. You can actually use that. You just flip the cap over and you can use that to tighten that core down. Make sure it's snug. Once it's snugged down, you can check it again. Next step will be looking at that cap and making sure that there is an O-ring inside. Now, whether or not you detected a leak through your Schrader core, it's still possible for that core to leak if there's a missing seal. It's always important to make sure that that O-ring inside the cap is present. This one has an O-ring, so we're going to definitely use that. If any caps do not have O-rings, you're going to want to just dispose of them and install new caps with O-rings. Now, another leak that we have here is on a pressure switch. You can see here we have a substantial amount of bubbles developing. Now, the tools that you're going to use for that will be a 7/16 inch wrench. That'll be a backing wrench for the Schrader core side itself, and a 9/16 wrench for a low pressure switch and your high pressure switch, and a 5/8 inch wrench for any of the pressure transducers. They're unfortunately different sizes. In this case, we have a high pressure switch, so I will use my 7/16 backing wrench. That goes on the Schrader core itself. And I'll use my 9/16 wrench and place it on that switch. Now the reason for this backing wrench is to keep the Schrader port stable as you tighten down the switch so it doesn't spin off. So we'll do that. We'll give this a snug. It doesn't have to be very tight. You just want to look for snug. The torque spec on these is 10 foot-pounds, but honestly you can just snug it up. After you have that done, you give this another spray and make sure you're done. That looks like that's the only leak in this compartment. Good to go. Okay, the another compartment that we want to take a look at is the condenser access compartment. Here you'll find your liquid lined service ports, sight glasses, filter dryers, and for the context of this training, the liquid receiver. So the liquid receiver has steel to copper brazes. We use a flux and a 38% solder for that. You want to give that an extra set of eyes in your leak search as well. Light oil residue from coil manufacturer may be visible on the outdoor coil after initial unit installation. This does not necessarily indicate a leak. Prior to investigating further, verify refrigerant pressures and performance. Typically, oil caused by a refrigerant leak will only be visible in a small section of the coil. If staining is near an accessible end of the coil, a repairable U-bend or header leak search should be performed. If staining is on the fin pack, use a refrigerant leak detector to verify leak location. Leaks discovered on the coil fin pack will require coil replacement. Fin and tube coils, shown on the left and used for the evaporator and heat pump, have large copper tubes. Microchannel coils, shown on the right and used in the condenser, have wave-shaped aluminum fins and tiny channels within their parallel flow tubes that carry refrigerant. They should be replaced, not repaired, if there's a leak. As a safety reminder, recover both circuits if brazing on an interlaced evaporator coil. To recover refrigerant from a circuit, connect a manifold gauge set to the liquid and suction line. The service hose connects to the recovery pump inlet port. Connect an additional hose between the recovery pump outlet port and the liquid port of a clean recovery cylinder. Starting at the unit, purge all lines to remove air. Place the recovery cylinder on a scale and zero the scale. Turn on the recovery pump and wait until system pressure is near zero, which may take several hours. Do not allow recovery pump to pull the system into a vacuum if a leak exists. This will contaminate the refrigerant with air. The system can now be purged with nitrogen and is ready for service. A vacuum pump removes moisture, air, and non-condensable gases, and also prepares the system for refrigerant. With system pressure equal to ambient, or 0 psi, install recoil removal tool with built-in shut-off valves on the liquid and suction line. Connect a micron gauge to the compressor discharge line. Use of a digital manifold set with built-in micron gauge is also acceptable, but may slow down the evacuation process. Hook up hoses to vacuum pump and energize the pump. After proper vacuum of less than 500 microns has been achieved, which may take several hours, isolate the vacuum pump from the system by closing service valves. If micron level remains below 500 microns, the system is now ready for refrigerant. To charge, use a refrigerant charge label located near each compressor for refrigerant volume information. There is a maximum refrigerant charge based on the space the unit is serving. You cannot exceed this because it is the basis for the building ventilation requirements. With the circuit still under a deep vacuum, begin weighing in initial charge using the liquid service port. Once refrigerant starts to pressurize the circuit, install Schrader cores and disconnect the core removal tools located on liquid and suction ports. Once initial charge is complete, energize the circuit and add in additional charge until charge volume is achieved. Hey, you've just watched a demonstration on diagnosing and repairing refrigerant leaks. We also covered refilling the system with refrigerant again to make it operational. We understand this has just been a baseline demonstration. If you have any more questions, please feel free to call us. Thank you for watching.